In this example, we'll graph the reciprocal of a quadratic function. In part A, fill in the table of values for the function y equals 1 over x squared minus 4. Bring up the table of values. Complete the table by evaluating the function at each x value. We should also get some points near the asymptotes. Evaluate the function at each x value. Now we'll move on to part B. Draw the graph of the function y equals 1 over x squared minus 4. State the domain and range. Bring up the table of values from part A. Draw the graph. There are two vertical asymptotes at x equals -2 and x equals 2. The horizontal asymptote occurs at y equals 0. The domain is x belongs to the set of real numbers with the restriction that x cannot equal -2 or 2. The range is y belongs to the set of real numbers and the y value will never equal 0. Now we'll move on to part C. Draw the graph of y equals x squared minus 4 in the same grid used for part B. Compare the graph of y equals x squared minus 4 to the graph of y equals 1 over x squared minus 4. Draw the graph of y equals x squared minus 4. Now we'll compare the graphs. First, the vertical asymptotes of the reciprocal graph occur at the x-intercepts of y equals x squared minus 4. Second, the invariant points, points that are identical in both graphs, occur when y equals positive or negative 1. When the graph of y equals x squared minus 4 is below the x-axis, so is the reciprocal graph. And when the graph of y equals x squared minus 4 is above the x-axis, so is the reciprocal graph. In part D, outline a series of steps that can be used to draw the graph of y equals 1 over x squared minus 4, starting from y equals x squared minus 4. Bring up the graph of y equals x squared minus 4. First, draw vertical asymptotes at the x-intercepts of y equals x squared minus 4. Next, draw the invariant points where y equals positive or negative 1. Next, determine the reciprocal values of any maximum or minimum points. The reciprocal of -4 is -0.25. Identify the regions where y equals x squared minus 4 is below the x-axis and where it is above the x-axis. Finally, draw the graph and erase the intermediate steps.